All right. Anybody got comments on that lot? As far as I'm concerned, this is all 99% speculation and very little related to reality. What are your views?
Beautiful theories. Lots of imagination is required by physicists, I'm sure. Just to think of these things, just to conceptualize what may be out there and seek mathematical proof, Derek. It's just amazing what sort of minds you have to be a physicist these days.
Yeah, personally, I'm not a fan of these highly speculative theories, which seem to have no relation to reality. It's difficult for me, but it's a lot. This is very complex stuff, and it's based on very complex mathematics mostly, which is probably beyond most of us. So that's a difficult one to swallow. But I think that physicists would be better off applying their time to stuff that they actually know exists, trying to logically link that into theories of what could be the right thing. I mean, the very definition, just the definition. I went on to ChatGPT and said, "What's the definition of a dimension?" I just want to pull that up. By the way, I've got a transcript of this whole video as well, so we can send that out to the attendees if you want it. Oh, here we are. Okay, let me share this. Where's my Zoom now? Share it. All right, so I mean, you think it's what's a dimension? It sounds like quite a simple thing, but it's fairly complex. Not to it. It depends what you think of a dimension as. Is a dimension a parameter? I think it's more than a parameter. They talk about an abstract dimension, which to me is really more a parameter. What's a temporal dimension? I don't know. To me, this stuff is too vague. It's not defined enough, actually. I mean, just this whole thing of four dimensions. I don't believe that, this whole thing of time being a fourth dimension, to me, doesn't make any sense at all. To me, time is an emergent property of it's a sort of holistic concept, abstract concept in the human mind to make sense of variation of one thing in relation to the variation in another thing. That's all it is. To me, time is not a single entity which exists as an actual thing. So, I mean, at best, what they say is the fourth dimension of time is an emergent dimension of variation of three other an object in the three dimensions relative to its translation in space. Yeah. So it's a sort of three dimensions, or it's a sort of subset of three-dimensional space at best.
What I was going to say, Derek, is I've never quite got my head around is why is there only one time dimension? They're talking about higher dimensions. I've seen in string theory, they're talking about a total of 11 dimensions. I've never understood why there's only just one time dimension.
Yeah. I've never understood why they need to go and find all those dimensions. It's to sort of make their mathematical concepts make sense more than anything else. There's no other.
I agree with you.
Sort of motivation.
Because you could come up with any theory of gravity of your like. If you write out a polynomial with as many terms in it as is necessary, you can make anything fit any graph.
Yeah.
So, no, I understand what you're saying.
All right. Hi, Jenny.
I was just Hi. Derek, I
Sorry,
was
is
just
that
fascinated
that
by...
Elaine?
Yes, sorry, yes, it is. I was just fascinated by those little topological, what were they called? I mean, even a Mobius strip blows my mind. What are those little multi-dimensional balls called?
Sure, I forget what the term is again. It's a Calabi-Yau shape or strip or something like that.
Yeah.
I think again that's the origin is in the mathematics where something it sort of I don't know, it can exist without infinities or something like that. You know, it's just something that is possible to exist, which is not nonsense. Put it that way. That's almost what it is.
But I just wondered if they'd actually managed to construct one, or whether that is pure computer generated.
It's as they said, they when they started out with it, they were sitting on a piece of paper writing out mathematical formulas and then arriving at one. I think what they did is, you know, sort of put in a whole lot of constraints until the thing could make a shape which had sort of contiguous edges and so on without vanishing into infinity at some point. So, and then they worked out how to write. Computers came along and they started writing software and started writing programs to actually, they put in the parameters and constraints that it has to comply to, and then the computer would come up with sort of mathematical geometric formulas which would arrive at a shape which could possibly exist. But what it means is I don't know exactly what its value is. Really.
Derek?
Is that Jenny now?
Yeah. Derek,
Yeah.
I just want to say, I agree that I shouldn't use this word, but probability of things like string theory is highly speculative. And they've been trying to find answers and things for decades now. But we also need to bear in mind, if you look at the history of cosmology, you know, for a long time, Earth was the center of the universe, but the technology then showed that there were other things happening. So we have to accept the possibility that, you know, something may actually arise in the future from wherever source, possibly from, you know, data and information, not from something tangible, which may support it in due course. We may just not be able to see things that are there now because the technology isn't able to do it. So we can't say no, but it may be highly unlikely.
As far as I see it, sort of logically, there are two ways to verify, you know, something like string theory. Now, the string theory, the thing is supposed to be at such tiny dimensions, tiny sizes, put it that way, that we just can't see it. So we don't have technology in a microscope which can resolve something so small.
Yeah.
So either someone has got to come up with a technology which can resolve something like that to actually say, right, I'm detecting this, so that's proof that it's there. Or else they must actually start at ground zero, at the smallest size of whatever structure they're proposing, and build on it mathematically and theoretically, and build on it until the end, and then sort of step by step, logically, you know, where you can say, right, if you do this, you get that. If you do the next thing, you get the next thing, until you arrive at something like an atom that we know by building on the thing that you started with. And then you can say, okay, this is the possible foundation of everything that exists.
Yeah.
But
well, that's what I'm saying.
There is no current way of linking that string theory to reality.
As yet, something could crop up because, yeah, until somebody invented the microscope and other objects, you know, technological things, we're ignorant about things that were happening in our world. So the technology potentially could you know, emerge in due course and prove or disprove some of these theories. We just don't know. So we just have to be open-minded, is what I'm saying.
Yeah, look, they are
Uh,
starting to work out ways of actually detecting, I think, the things like a photon and measuring what's the size of a photon and this sort of thing with very ingenious methods. But I mean, like a photon is, I don't know what the scale is, but let's say a photon is 1 billion times bigger than the string that they're proposing, or maybe more. Maybe there's a bigger difference, it's going to take a while before we get to resolving something that small.
Yeah, I mean, it'll take time, but it's possible. So if you look at history,
I think it'll take
our
1 million years at
understanding,
least.
well, who knows? Because, if you look at history, things were developed unexpectedly or from different places and sources and answered certain created this, more complex cosmology. So although we're working at tiny, tiny amounts, there's nothing to say it can't happen. It may not. We just have to be open-minded to the possibility.
What to me is interesting in this video is the Kaluza guy who just went and put in that 5-dimensional thing and mathematically worked that out. And then he, I suppose, mathematically proved by manipulating formulas that it is equivalent to the general relativity formula, but including electromagnetism. So that, I mean, I don't know what the mathematics is behind that. I mean, just the formula for the general relativity to me is too complicated to comprehend.
But we can't say it's impossible. We have to accept that it is possible.
Yeah.
Until proven otherwise.
Yeah.
Yeah, I think that even before proven, the actual physical effects of Einstein's theory in terms of an atom bomb managing to end a war very quickly, or just the cancer treatment using photons to actually do things as they float through the body. We still might not know what it is, but already the physical effects are there. So I think it's not too different to sort of psychology, where when you had sort of Freud kind of giving all sorts of treatments based on dreams, and they weren't provable, but the fact that he could actually get to the bottom of hysteria and actually treat people because he was using almost gut feel sort of stuff that had happened. And then the behaviorists came along and like Derek suggested, they had to get down to, unless the thing was scientifically proved, you couldn't use it. And it just looked like it would never be able to build up to anything like where you could treat somebody through that means. But as it happened, so they've almost overtaken each other now with all the brain mapping and the ability to, get computers to actually show that it's not that compartmentalized. It's just the interaction of all these things that is the reality. And as you say, I think that's the world today, that you've got to accept that it might take our science. It helps when we actually out there, like having Musk out there doing things with the unknowable. It does actually speed up our knowledge. The fact that all those satellites out there might be creating a lot of mud or something that we can't see through it, only be able to see space through things in satellites and out there. It's part of what we have to accept in terms of trying to understand the whole thing, I think.
Yeah.
Derek, if I
carry on.
Yeah. Sorry, Derek, can I just add something? Thinking about the physicists are constantly looking for this ultimate knowledge, if you like. And I think just to share, to expand on what Jenny was saying, that, we've had tremendous technological developments that have led to further and further experiments and understanding and discoveries. And I think particularly of CERN, and now they're considering a far larger CERN, I see. Some people are very skeptical about it, but the point is looking for the ultimate answers. Are we going further and further? And for instance, I think the James Webb Telescope is the result of the need to look further into the past. And already it's shown us some very interesting, not only images, but understanding of where we are in the universe. So, I think that's where the physicists are trying to go and see what we need to measure and try and develop technology to be able to measure it. So who knows where we might end up.
Yeah, Webb is absolutely fantastic. It's still a lot of unexplained stuff that it has found, and it's still yet to be explained, and it doesn't quite fit in with current theory and this sort of thing. So that is absolutely fascinating. The other thing is, this thing where they talk about actions. He should really in a video like this, he should say this stuff is totally speculative and it's never been found. He should. He goes on talking about a lot of stuff, but actions is a theory and it's never been found. I think you should rather point that out. But there are also, though, things. I remember that, what is that German guy's name who had a friend of his gave us a one talk. He's been doing research at Antarctica. And he told us some of his, at that stage, unpublished stuff that they'd found and wasn't quite proven yet. And I've never heard anything since from it, but they had detected antimatter, helium-4 antimatter at the detector particles, helium-4 antimatter particles at their detector in Antarctic. Now, helium-4, the normal helium-4, can only be manufactured in the processes that happen within a sun. So the logical conclusion is that if you find antimatter helium-4, it could only have been manufactured in an antimatter star. Now, that's a little bit mind-boggling to think that there are antimatter stars, entire suns made of antimatter out there somewhere. According to the logic, that's what it has to be, which nobody's ever detected. So, imagine. Maybe these. I don't know. So yeah, there are incredible stuff out there which we've yet to find. So, David, you've got a question, comment?
Derek,
Is it Elaine?
no, actually, I'm back again. Derek, I was just thinking, it is so difficult to conceive of that which we've never experienced. We can't, we live in 3 dimensions, so we can't imagine anything else. And when we can't conceive of anything or see it, I think mathematics is the only way in which you can approach that which you cannot conceive of. So maybe that's why they need all the maths.
Yeah, I think, those are all almost created to sort of explain the mathematics. But as far as I'm concerned, that's all very fine and good and very, very well. But then you must take that mathematics and link it up to reality. Show us where the logical path lies to reality. Without that, it's meaningless. Pure speculation.
Yeah. But so much is maths. Quantum mechanics is all mathematics, isn't it? There's very little that's real about that.
Yeah, quantum is sort of, it's quite different. There was no, the quantum, as far as I understand, the quantum mechanics standard model and so on was just formulas that some geniuses wrote down. And there was no sort of way that it's not linked to anything where they came to the conclusion, okay, this is like that and that is like that, therefore this formula must look like this. They just wrote down formulas, and those formulas say, okay, according to this formula, we've got to find this and got to find that and find this particle, and something's got to look like that and be structured like this. And then they went and found, and all the findings are borne out to actually exist. As predicted by the mathematical theory of quantum mechanics. So in that way, that's sort of what I'm trying to get at, is what they should, until that happens with string theory, to me it's just pie in the sky, really.
Derek, I just wish I was clever enough to understand it all. I really do.
I'm clever enough to know I don't understand it. Okay. Anybody else got some insightful comments on this? Does everybody want the transcript? Can we just send it out? I presume Peter will just send it to the attendees. I think if, it's sometimes sitting and listening to this, it's all a bit mind-boggling and overwhelming. Often just much easier to read through the text. Go through it slower and make sense of it that way. So let's try and do that. If you've got any comments after you've read this, you're welcome to send them to us. And say, oh, you didn't point this out, or you didn't notice this, or this is an interesting point, or whatever. So yeah. All right. I think, the highfalutin scientists are all learning all the time. So we've just got to try and keep up with them. Okay. Anybody ready for supper? Shall we wrap it up? Anybody got something to add?
Derek?
Go ahead.
Terry Thompson here.
Hi, Terry. How are you?
I'm the proverbial guy with the boxing gloves trying to count the grains of sand.
Yeah, I think we all are on this one.
And it was actually always my problem studying physics and science at school and wherever, that I too could only be convinced about things that I could kind of literally see and feel and touch and mathematically justify. But I also do believe that the imagination that some of these scientists have is the only way forward. We have to open our minds to any possibility, even though it might seem crazy. And I guess that's why Musk is where he is, because he does exactly that.
I think Einstein is just still the shining example of how to approach these things. He would take a situation in real life, sit and think about it, and then say, okay, but what happens if we push this parameter to that limit? Then where does that leave us, sort of thing? And that's the way he analyzed everything and thought about everything, and eventually tried to put mathematical formulas to it and came up with all these fantastic theories and so on. That I can live with. I don't mind complexity in a thing like that, because it's based on reality.
Please thank your wife, because the only thing I understood in the presentation was her message to you about Woolworths.
Oh, did you see that? Okay, because the screen was shared. All right. Yeah, I've got WhatsApp pops up on my computer. I've forgotten that you can see everything that's on my screen.
It was most
Thank goodness it wasn't some rude message or something.
Yeah, it could have been worse.
Okay. All right. I hope you enjoyed this, and maybe the next one will be a little more accessible. Let's pull up the list quickly, actually. We're in our history of the universe. Let's just pull up the list quickly. The next one in the list is the last one of the original 17, which is what actually are space and time. Yeah, that'll be one of my favorites. So let's see. There are actually, they've added on a whole lot, over 30, I think. So there are a few to follow on from that. But this is the last one of the original. So next month, we'll do that one.
Well, we look forward to it.
Okay. Thanks for your attendance. And we'll see you next time. Enjoy the rest of the evening.
Goodbye.
Cheers.
Yep. Thank you very much. Cheerio, everybody.
Bye, everybody.
No, thank you, Derek. Good night.
Cheers. Bye.